That then, ice block, then will float in the surface current to another location. As it's floating, it gets smaller and smaller and smaller and melt. And as it melts, all the sediment trapped in this ice block will fall to the ocean floor, and that's ice wafted debris. And it looks like this, for example. You can see that they're quite rounded, probably because they're being transported in the ocean. These pictures here at the top are just looking at how ocean cores are collected, marine cores. So if somebody, there was some confusion with you guys with the data analysis practical, but also in last year with the same practical, is that marine cores means sediment cores from the bottom of the sea. It's not a core that anything to do with the water column. It's just sediment collected from the seabed. So this is how it's done. It's done off large boats, with very, very large pieces. This is coring equipment here. It's a very gigantic core, and it's lowered down into the sea, and then the core is collected and brought back up again. It's a very large-scale version of what we're going to do, what we do on land if we look at peat logs. Has Chris talked to you about coring in this model? He mentioned that he wants to take a course. Is that in what? We were thinking about taking you in a few weeks to go and collect your own core to then work on in one of the labs. So I'll find out more about that and let you know the timetable. It's timetabled in the model. But it's not that type of core. It's a core. You guys are all probably really quite competent on boats and kayaks and things, and you can collect all sorts of exciting cores without falling in the sea, but I'm not.
So no trip to Iceland next week or something?
That would be nice, wouldn't
it? Yeah, I'm up for a quick holiday, like, if you want to.
I'd be quite happy to do that. We can fly from Bristol now. It's really quite cheap.
Win-win.
Long weekend.
So if nobody comes to the lecture next week, you've all suddenly won the lottery and have gone to Iceland. And left you behind will be really jealous.
Come with. Skip all your lectures.
It's a bit snowy at the moment, so.
Oh, it's a shame.
Oh, it's a shame the plane won't be able to take off to come back.
Oh, damn. Bugger. You're stuck in the snow for a couple of weeks.
I'll come back to these things. Don't let me get distracted. You distract me about talking about Iceland because we'll just never make it. Okay. Okay, so then, right, so when we go to Iceland, we can collect terrestrial sediment archives. So this is the sort of thing that Chris does a lot of his research and looking at lake sediments and peat records. I have been in teams looking at collecting lake sediments, but I like to do it myself. So far I haven't fallen into the water, but I'm definitely not the one that's led me to a boat. And I have looked at peat records as well, and that's something that you will do. You'll encounter these in this module and in key skills. What we were thinking about doing in terms of coring, or how we got distracted by the whole Iceland thing, we were thinking of taking you to salt marsh area and collect some cores for you then to look at in the labs. So hopefully we can still go ahead with that. But if Chris has not mentioned it to you, maybe it's not certain, so I better not mention it already. Okay, so we're going to go through these different records. I'm going to come back to, so this terrestrial marine section of the module is followed up by a section in the following week looking at chronology. And there's quite an overlap between chronology and terrestrial marine sediment records because we use all the papers that talk about the different types of sediment and the proxies within them for climate also usually use chronology to link their cores or link their records. So there's also some overlap with how we use things. For example, we can use tree rings to get some idea of, and speleothems to get some idea of climatic conditions as a proxy, but we can also use them for correlation. So I'm going to talk more about these now, particularly peats, and come back to these a bit more when we talk about chronology, and I'll try and make it clear when we do that about which bits relate to chronology and which bits relate to actually what the proxies tell us. Do you know what I mean by chronology? Actually, it's kind of worth asking. Okay, so it's some nods. So chronology being how we tie one record to another. How we say this is the same time, even if you don't know what date it is, we know it's the same time. And the proxies, what's a proxy? A climate proxy? Or proxy? You probably know this is probably, I'm asking you a naughty question, maybe? I don't know, there's less noise, because I'm like, I'm not going to say. You can say no, definitely, I'm not going to say. Okay. Proxy means that you look at one record, say we're looking at isolated debris or quartz grains, and we infer from that climatic conditions. So we're not actually, don't have anything, we're not actually going with a thermometer and measuring temperature, we're not measuring pressure, air pressure or anything like that. What we are doing is measuring size of quartz grains or the number of quartz grains in the isolated debris record in a marine core, for example, making